going to hit the record button so that our session will begin to be recorded. Thank you all for joining us. We're delighted to have you here this morning. Our first presenter this morning is Mercedes Garcia Martinez. She is the Chief Research Scientist at Pangeonic, where she researches and develops Pangeonic MT Echo, providing neural machine translation, anonymization, classification, information retrieval, and other services from documents. She's an active participant in NTEU, which you will hear about this morning, MAPA and the European CEF projects. Her PhD is from the University of Le Mans in France and focused on factored models using linguistic information and neural machine translation. She's also taken specialized courses in neural networks, machine translation, translation technologies, and research on the translation process. She is well published with more than 50 scientific publications in international journals and conferences. And Dr. Garcia Martinez is joining us live this morning. We are going to play the video of her presentation, and then she will be available for on-screen live Q&A, both following her presentation as well as during our question and answer session at the hour.
Thank you.
So if you will bear with me for one moment while we present the video. Please do alert us in chat if you have difficulties either seeing or hearing the video presentation.
Hello, my name is Mercedes Garcia from Pangeonic, and I'm going to present you neural translation for European Union, which is an European project that has as a partners Pangeonic, Tilde, and Cantan MT translation companies, and the AI Secretary of the Ministry of Spain. The objectives of the project consist of building state-of-the-art neural machine translation models for all the European Union official language combinations. So there are 24 languages that in total is 552 language combination models. And without using a high resource language as a pivot. We have collected clean training data for the resource language, the high resource languages. We have collected 15 millions of segments. For the under-resourced language combinations, between 10 and 12 millions of segments, and for the ultra under-resourced languages such as Maltese and Irish, we have collected 10 millions of segments. We are also uploading Dockerized versions of the MT engines to European Language Grid, and the collected data to ELRC share for the use of public administrations. The project started September 2019, and it will finish by the end of this month in August 2021. Here you can see the language metrics with all the language combinations and models. And each company has built the models for all the languages as a source to these specified target languages. So we split it in three, all these models. We have performed an evaluation for the NTEU engines. For the domain of public administration, we took the test set from DGT, and the test data set is the same for all the languages. We used the whole document, so this is like a real scenario. So we didn't randomize the structured sentences. Firstly, we perform an automatic evaluation using a test set of 2,000 sentences with one reference that has been isolated from the training and the development data. The automatic metrics that we have used are BLE, TER, F-measure, and perplexity. Here you can see the results for the engines translated into iris. So we got very good results with high scores. Not that high for Croatian to iris, but it's not bad. And then we have performed a human evaluation. For that, a native speaker of the target language have evaluated the translations because it's difficult to find bilingual evaluators. Almost impossible to find someone that can understand Greek and Croatian, for example. And we have used Google Translator as a benchmark to compare our translations. For the evaluation, we have built a platform called MTT, Machine Translation Evaluation Tool. And this platform, the code will be published in GitHub as an open source. The evaluator in the platform can see the source text, the reference, and the two translations, the NTU translation and the Google translation, but the evaluator cannot identify which one it is. So this is a blind evaluation. And the evaluator has to assess its automatic translation using a slider that allows to choose a number in the range of 0 to 100. The number of sentences that the evaluator assesses is 500. That is a subset of the 2,000 that we have used for the automatic metrics. In order to mitigate the human bias, two evaluators have evaluated each sentence. This is the evaluator's view in the MTT platform. This is an example of translation from Irish to Greek. Here you can see another example, and this is a translation from Slovenian to Finnish. We can see that for this translation, I think is not complete. So the evaluator introduced the number 41, and this one looks better, and the evaluator introduced the number 92. There is also an administrator's profile that can check the translations. And also the administrator can manage the projects and split the task to the evaluators and can see the progress of the evaluation and which ones are complete. So let's see how far we are and how NT engines work. So we see that for uncommon language combinations, NTU engines are far better than Google, where we think Google uses a language to pivot. And NTU is also better for more common language combinations, as you can see. And for the engines involving English, the differences are less significant because we think Google uses English as a pivot language. So the models are better, but we are still quite good compared to Google. Only 2 engines have yield worse results than Google. Both have Maltese as a target language. One of them has English as a source. We have retrained these models, and now these models are being evaluated, and we hope to have better metrics for these models. And the results show, in general, that the 90% of the NTU engines are better than Google with statistical relevance, and the other 10% are similar to Google or slightly better. Thank you for listening. And now I would like to reply any questions or comments.
Thank you, Mercedes, for the presentation. We'll now ask Dr. Garcia Martinez to answer any questions that may arise. Thank you all for your attention and for joining us today.
Welcome. Thank you for listening.
One of the questions that came in regarded the flavor of language of Google. Did you compare to generic Google?
Yes, I did. Yes, we did that with generic Google. Yes.
Thank you.
Another question is if
Yes.
I compare it with DeepL. No, we didn't. We could, yes, but well, we wanted to compare with something general and available for all. Yes. And yes, the problem with DeepL is that we don't have all the language pairs. Yeah.
Thank you very much. Another question coming in. Why did you use a scale of 0 to 100 and how did you explain it to evaluators?
Yes, well, this is also used in WMT conference, this range. So it's the direct assessment. So this is common use for evaluation in MT. Yes, we could use another range, but this is something more generic. How we explain it to them? Well, this is how, well, if they see it better, they go to better range, but it's something that later we normalize, and we have also several evaluators, so it's something that we normalize, because I think with experience we see that if maybe in the first hours of the day you are happier and you range everything much higher, and at the end you range it lower. So we try to do this normalization, but we don't give a very specific ranges like this is something, or is what they feel, and we normalize this. This is what they do in WMT as well.
Several very good questions coming in. One from Professor Melby. He notes there's a lot of discussion within Europe regarding this service, particularly when raw or unedited output from the EU NMT system is appropriate and when is it not appropriate. Could you please comment on use cases?
Oh. Raw unedited output. When is not appropriate to be used?
Or raw MT in particular.
Yeah,
yes.
well, we did also these models because they are in domain for public administrations. So if you have it in domain, probably the output of the MT is much better, and it will be more appropriate than a general model like Google. In which use cases? Well, we have the AI Secretary of Spain, for example, for working in tourism. We work with them in one project, and they are also trying this in Poland for the public government. Yeah.
And would there be perhaps a use case that you might speculate where the raw output would not be appropriate?
Yeah, well, this is trained with DGT data mostly. So yeah, I guess if the domain is close to this, it will be okay. But otherwise, probably it will have to be edited or adapted again.
That's a very interesting statement. By the way, context, I am the
Professor
official.
Melby, welcome.
Thank you. I'm here. I'm not speaking as a professor, although I am an emeritus professor of linguistics. I am the official representative of the International Federation of Translators, FIT, and the European Regional Center, FIT Europe, has been involved quite actively in the question of how this particular system has been presented to the public in the and this question of when it is appropriate to use raw machine translation and not, especially for websites, localizing websites that are public facing. And there's quite a debate about this, actually a vigorous debate going on. And even when it is in domain, clearly, I mean, I've only been involved in machine translation since 1970. So I'm a relative newcomer. That's American humor. But this question has come up repeatedly over the decades of in domain. Certainly it helps a lot for the training data to be in domain, but is that sufficient to put to use it for public facing information going out to the public, especially when there could be a risk associated with a mistranslation without editing? This is a very important question to FIT Europe.
Yeah, I understand. Well, that our ranges from human evaluators, it was close to 90, so it's quite high. So if there is an error, it's not so important, I guess. But well, it depends what is your goal. If you want a very perfect translation, I think everything has to be checked. But even if someone is checking, maybe another person has to recheck. So this depends on your goal. If the problem also is that we don't have resources to translate everything in all the languages. So this is a way to have information for all of us in Europe.
And
so it's a cheap way to have information for everyone. So I think, yeah, and we don't have, probably we don't have resources to do it for all the information.
And I'm going to jump in. Thank you. We're going to save this very interesting question line and several other very good questions for the question and answer to come.
I will reply the questions later if we don't.
Yes, so I have several queued up for you,
Thank you,
Professor Garcia, and thank you, Professor Melby, for the question. And with that, I'm going to turn it over to Laura Daly to host and to introduce our next speaker.
Oh, good. I found my mute button. I couldn't find it. Good morning and good afternoon, everybody. So I think you're seeing my slides, I hope. And in these slides, I want to say that we are going to be hearing from a very interesting LSP regarding a data-centric approach to real-world custom NMT for Arabic. Do I have Rebecca Johnson with us?
Yes, I'm here.
Hi, Rebecca, and Ruba too.
Yes.
Wonderful. Before
Yes.
I introduce you, I'm going to remind everybody to stop by the booth and grab a person that you see from our lovely sponsors that are Vistatech, and my screen is being hidden. Why? I know it's Intento and Vistatech, and what's the third company?
Yandex Cloud and Microsoft.
Thank you so much. Why can't I see anything? Well, I can't see anything, but you guys can. So I'm really excited to hear from you, Rebecca and Ruba. So our next speakers represent the company Tarjama. Tarjama means, does anyone know? Translation in Arabic. And how exciting, it's a female-led LSP and language technology company in the MENA region with its proprietary NMT system for Arabic. And Rebecca is the head of Tarjama's AI department. She has a PhD in linguistics and 20 years of academic and commercial experience in the field of language technology. And Ruba Jaikat is leading the deep learning engineers at Tarjama in Amman, Jordan. She's an experienced deep learning scientist with focus on NLP, NMT, and speech technology in Arabic, English, and Persian with a BS in computer science. So I'm really looking forward to this. Let's not waste too much time and let's get to it. And let's see if you can share screen. I'll make you a participant. Let's see, I'm gonna transfer it to you, right, Rebecca?
I think it's working now, right?
Oh, yes, I see it. Okay, great. Take it away. Thank you.
Okay. Thank you for the introduction, and good morning, afternoon, or evening, wherever you are. In my case, buenas tardes from Spain, and in Ruba's case, in Amman, Jordan. So we want to show you our data-centric approach to building custom NMT for our customers in the MENA region, and the impact such a model has had on a real-world client project. So the model is now assisting our translators in translating e-commerce data from English to Arabic. But first, I want to introduce very briefly our company. So Tarjama is a language service provider, might be a small global player, but it's dominant in the MENA region. In 2016, Tarjama launched also YouRead, which is now one of the region's largest digital marketplaces for freelancers and specifically focused on translators. The company is currently transforming into a language technology provider, and I'm helping it in that journey. We have our own TMS system as well as our own machine translation system, and both with focus on Arabic. And as Lara said before, it's a female-led company. Our CEO is a Jordanian entrepreneur. She's built up both YouRead, as I mentioned there, and Tarjama. We are now over 150 employees. We have customers such as McKinsey, Ernst & Young, Amazon, and Noon that we will mention today. So during the past 2 years, the AI team at Tarjama has developed a neural machine translation engine. It has been built by using all the in-house data produced by Tarjama's expert linguists. It's high quality data, and it covers various business domains, legal, health, finance. It's mainly for English to Arabic and the opposite direction. In addition to this, we have been adding gold nuggets from external data sources to further enrich the engine. Currently at Tarjama, 35% of the translation production is done using this machine translation. And when we compare our engine to stock engines by the big tech companies or competitors, we outperform them when it comes to translating from English to Arabic in the type of domains that our clients want to translate. So for our clients, our NMT is normally the best option. And this is the fantastic team I have sitting in Amman, Jordan. They are behind the NMT engine and behind the work we're presenting here today. This spring, we have been focusing on taking forward best-in-class machine translation by tailoring our NMT engine for them on their data. I will hand over to Ruba, who's leading the deep learning engineers over there in Jordan, so she can introduce us all to what we call our tailoring process.
Okay, thank you, Rebecca. Hello, everyone. So you might be wondering why we're using the word tailored instead of custom NMT models. Well, simply because we're taking the customization process into a whole new level. So not only that the client data is partially used to train the NMT engine, we also have a defined process, which we call data-centric approach, which helps us to select the gold nuggets of the client data, take into consideration the translation guidelines, and we make sure that the model generalizes well on other data sets. Finally, we have our linguistic quality assurance experts who drive us to deliver the highest quality model and make sure that the model performs best in class on the customer data. Now, let's delve into more details on how we achieve that by explaining the development cycle of the tailored NMT models. So here we have 4 steps which we follow each time we tailor a new model for a specific client. So the first step is data acquisition and analysis. The second is data pre-processing and filtering. The third is adding external data, and finally, model adaptation. For the first step, data acquisition and analysis, because we know that the quality of the data is very crucial to the success of the tailored models. Once we receive the data from the client, our linguistic quality assurance experts, they analyze the data by evaluating the quality of the data, also pinpointing the types of errors they find within the data, identify the different domains, as well as any translation style or guidelines. For the second step, data pre-processing and filtering, as William Shakespeare once said, all that glitters is not gold. So here at this process, we aim to only select the gold nuggets of the client's data by passing it through our advanced data pipelines for pre-processing and filtering. Based on the analysis done in the first step, we might need to adjust the data pipeline or pass the data through different filtering mechanisms, such as language model filtering, blue filtering, or others. So now that we're well acquainted with the client data, we can carefully select the out-of-domain data to add together with the client data for training the tailored NMT engine. This is for the purpose of building a robust engine that generalizes well on the other data. The criteria we follow to select external data is 1, the quality of the data, where we only select the high quality data. Second, the domains, where we have a trade-off between selecting a diversity of domains, which will cover the all aspects of the language, also the domains which overlap with the client data. And the last criterion is that translation style or guidelines, where we try to look for data that is similar to that of the client in this aspect. Before I move on to the 4th and last step, which is model adaptation, I want to bring your attention to the first 3 steps, that they are all about data, which is therefore we call it data-centric approach. If you can see, we do not, the actual training of the NMT engines do not start before going through an extensive process of evaluating, pre-processing, and selecting the data that best serves the tailored NMT engine. So the last step is model adaptation. Here we run plenty of training experiments where we tune different hyperparameters, fine-tune on client data, as well as using weighted training. Overall, when we're done, the best performing model is selected based on both automatic evaluation metrics and manual evaluation that is done by human experts. Thank you.
Okay, so we apply this process that Ruba just explained to tailor a model for an e-commerce client called Noon. Noon is a big e-commerce retailer in the MENA region, a competitor to Amazon. They provided us with 3 million bilingual segments of high quality translations together with their guidelines and metadata. So based on this data, we tailored a model for them following the approach that Ruba just described. So let's first have a look at their data to give you some insight. So as you can see here, e-commerce data is full of numbers, units, abbreviations, and article numbers. It's full of named entities and product names. It's lexically diverse, information rich, and you can also see that the sentences are very condensed. So we built a model based on that data, and when we evaluated it with automatic metrics, our tailored model that you can see to the right here performs substantially better on the client test set here in green. In fact, we actually got an increase of 57% in blue score compared to our generic model. And we see similar patterns for other automatic metrics, such as character F, for example. At the same time, we can see that it still performs well on our generic test set. We had a slight decrease there in performance, so it seems to generalize well, which is what we are looking for. To actually understand how well the model was performing, we carried out a manual evaluation of 500 segments. We follow the MQM approach. We've adapted it a little bit to our needs to identify the different type of errors. And the most common error were mistranslations. And then on a higher level, based on that evaluation, we can see that 63% of the segments were perfectly translated with good fluency. Our translators would have had to do minor review of around 24% here, a deeper review of around 12%, and then we can see that it still performs some nonsense sentences or non-understandable sentences here as well. And this is how it translates the model. Some examples, we can see that it is robust to erroneous input, as in the example down here, and that at the same time it can translate expressive product descriptions as the first one here. Well, in fact, the biggest problem we've had in the project was to get the Arabic to show up nicely here in PowerPoint. PowerPoint is not very happy with Arabic, and I hope it's finally showing off nicely here. So our linguistic QA team felt very confident with the quality of the model, so we integrated it into our TMS system, Cleverso. And it's now used and assists 60 to 90 translators that are working on this project for noon and helping them to translate e-commerce data. But we wanted to understand the impact of the model. So after a month, we contacted the project team and asked them how things were doing. They told us that they were now delivering the triple volume of translations to the client, that translation costs were down by 50%, and that they could see improved consistency and quality of the translations delivered. In order to compare the tailored model versus if they would have used our generic model, we performed a productivity test or carried out a productivity test. And from that one, we could see that they were saving 38% in time by using the tailored model versus if they would have used the generic model. So this looks good. The PM is happy, the client is happy, but we wanted to know if what would the translators say. So we carried out a survey with 50 translators working on the project. Most of them have post-editing experience. And according to them, the tailored model helped them most with terminology and with all those units and numbers that you could see before in the data, as well as with consistency. It has learned e-commerce vocabulary, according to the translators. They also told us in the survey that they could see that it worked better for some categories, such as fashion, than others. We also asked them if they found the tailored model helpful, and there was only a few, 2%, that didn't find it helpful, and most of them find it helpful or more helpful than Google Translate. There are some maybe answers here, as you can say, because there were some translators that didn't want to give a clear response yet because they hadn't used the model enough. As we were very early on here, we want to follow up on this. But in general, the translators were happy, the PM is happy, and our client is happy. Our stakeholders are very happy about this. And we in the AI team are now happily delivering these tailored models to other clients, as well as following up and improving these models that we have already delivered. Thank you for listening, and we welcome any questions.
Thank you, ladies. Okay, so do we have any questions? Please type your questions in the chat. And I was wondering if you have had other types of clients, like other verticals of clients, go through this same model, or have you mostly worked on e-commerce?
So we worked on e-commerce for another e-commerce client actually, and we worked on business consultancy as well. So yes, we have worked on those and with very positive results as well. And in this case, for this project, the data was very high quality. For the others, when we talk about getting those gold nuggets for other clients, as the data wasn't such high quality, we actually got rid of more data and less data was left in the end, right? But still the models turned out much better than the generic model.
Very good, interesting. I see a question here from Judith. How much training data was, you may have mentioned this, how much training data was available?
So in this case, 3 million segments. So quite a lot in this case. But for other clients, it's been much less, down to maybe 100,000 K or something.
And from Konstantin Dranch, how did you select your methodology?
This is some, yeah, go ahead,
Go
Ruben.
ahead.
No, go ahead.
Okay. Since the beginning, we believe that the quality of the data matters more than the quantity. So we, since we began developing MT engines at Tarjama, we have tried lots of experiments focusing on both quality and the quantity, and we did find out that the quality matters more. So we focused on, and because we have like a network of experts and linguists in the company, we have our internal translators, we have linguistic quality assurance experts here. So they helped a lot, and their feedback was significantly affecting the model. So based on their feedback, we constantly improved our methodology until we came and reached this approach.
Very good. Okay, I'm just going to try and go a couple more before the top of the hour, or the 20 minutes. So one more was, this is interesting. Regarding the format of the Arabic source text, do you have a robust Arabic OCR software to input the data?
No, we don't. We have explored building our own OCR software because there are not many available. It's tricky to do. In this case, we were getting the translations from them through their system where they have been translating, right? So.
Okay, and we'll probably have to table some more of these questions for the Q&A, but the last one was, when you're looking at the survey results, did you gain any insights into the qualities of those translators who did very well compared to those who did not? So did you notice what made a difference in terms of efficacy for post editors?
Yeah, I don't know if I understand the question. So their quality or our quality?
Which type of people were better post editors than?
Okay, no, we didn't have access to them to see that. So that's something we're building into the system now, so we can follow how they are post editing, and then we'll be able to follow up based on who they are. No, we didn't have any relation between the survey and who they were. So it was anonymous, the survey. Yeah.
Okay, so thank you everyone for those questions, and we have a couple more that we will table for when Pete goes through on the Q&A. So let's thank our audience, or sorry, our guests here, and thank you so much for presenting. And let's move on to our next session. Pete?
Thank you.
Thank you, Laura. And Parik, I believe you are a host, so you could begin to share your screen, hopefully, and we will see your slides and later your video.
Okay, yep, let me do that.
And while he is doing that, let me do our brief introduction of our third speaker. Dr. Parik Sheridan is the Vice President of AI Strategy and Operations at RWS Language Weaver, a company and a tool that have been much in the news these past few months. He was previously co-founder and chairman of Iconic Translation Machines, a company that was spun out of MT Research at Dublin City University in 2013 and was, as we have learned, now acquired by RWS in 2020. Parik has an extensive background in NLP and MT, including a master's degree in computational linguistics and a PhD in computer science, a perfect mix. He spent 10 years working on commercial NLP at TextWise in Syracuse in New York, followed by 12 years at the ADAPT Center in Dublin, Ireland's National Centre for Research and Development in Digital Media and Language Technologies. And with that, I will turn it over to you, Dr. Sheridan. Thank you for presenting this morning.
Thank you, Pete. And I've always wanted to use the cooking show quip to say, here's one I prepared earlier. So I'm going to play the video of my presentation rather than doing it live. Thank you for the introduction. And yes, today I would like to present our work on building MT systems in low-resourced EU languages for public sector users in Croatia, Iceland, Ireland, and Norway. So as you all know by now, RWS has reintroduced the Language Weaver brand. I came to RWS myself through its acquisition of iconic translation machines back in 2020. But if you are interested in the longer history and background of Language Weaver, I'd encourage you to visit languageweaver.com to get more of the details. So I'm presenting today work that we did within the Principal project, which was a 2-year project funded by the European Commission through the Connecting Europe facility. And the project was focused on collecting data to improve machine translation quality within the EU digital services infrastructure, particularly for prioritized low-resourced EU languages. And the main aim of the project then was to identify, collect, and process high-quality language resources for those under-resourced European languages, which are Croatian, Icelandic, Irish, and Norwegian, both Bokmål and Nynorsk. So the project was led by Dublin City University, and we worked together with the Language Bank at the National Library of Norway, the University of Iceland, and the University of Zagreb in Croatia. And the work that I'm presenting today is very much a collaborative, the result of a collaboration between all of the project partners. And I want to acknowledge the contributions of my colleagues in the work that I'm presenting today. So while the Principal project, as I said, is primarily a language resources project, we did want to include machine translation work within the project, really for 2 key reasons. And the first was that by benchmarking and evaluating machine translation systems that we developed within the project, we were able to attest to the value of the language resources that we were gathering for machine translation, and thereby attest to the quality of those resources. And secondly, by granting free access to the MT systems for public sector bodies who worked with us in the project and who donated their data for the European language efforts, this was seen as an incentive to sort of quid pro quo for their participation in the project. And those public sector bodies that I refer to who donated data and also gained access to the MT systems, you'll hear me refer to them as early adopters, which is a language we used within the project to describe them. And so as a starting point, at the beginning of the Principal project, in gathering new resources for these languages, we wanted to ask what resources already exist. And ELRC Share is the language resource repository of the European Commission. And so that's where we started. We downloaded all of the resources that were available from ELRC Share. A quality review was conducted by the Principal project partners in each country. And we then cleaned and filtered the resources that were available and used them to develop a baseline MT system for each of the languages. I'll refer you back to an MT Summit paper at the last MT Summit in Dublin, where Iconic presented and described the data cleaning and processing pipeline that we use in building MT systems, which is why you see a lower number of translation units used in the MT systems than were originally available. So the Principal project then proceeded in 2 phases. And in each phase, we worked with a set of early adopters, public sector bodies from each of the countries that we're focused on across Ireland, Croatia, Iceland, and Norway. And so I'll step through the data that was provided by each of these public sector partners, the MT systems that we developed, and then I'll highlight a number of these early adopters to present and discuss the evaluation that they conducted of the resulting MT systems. So as we work through each of the countries and each of the set of public sector partners in each country, In Croatia, we worked with the Ministry of Foreign and European Affairs, who provided just over 100,000, 115,000 translation units of their data. We got over 22,000 segments from other data providers in Croatia and combined those with the baseline data of almost 3.9 million segments to build an MT system for the Ministry of Foreign and European Affairs. We also worked with an LSP in Croatia, Cyclopia, for 2 different engines in different domains. They provided just over 36,000 segments for an e-procurement engine, which was from Croatian into English. And then they provided over 76,000 translation units for an engine English into Croatian in the domain of e-health. In Irish, we worked with a number of different data providers, but we ended up building 2 specific MT systems. The first was for Foras na Gaeilge, which is an organization whose mission is to promote the use of the Irish language. They provided just over 60,000 translation units, English and Irish. We also had data from Rannog and Astrakhan, which is the translation unit of the Irish government that looks after translating Irish law, which by law needs to be translated from English into Irish. And then we had some additional data, almost 65,000 segments from the Department of Culture, Arts, Heritage, and the Gaeltacht. Again, a government department, one of whose responsibilities relates to the Irish language. We then built a second engine using similar mix of data for the houses of the Oireachtas, the Rannog and Astrakhan, the translation unit there. And that used our baseline data together with the data from Rannog and Astrakhan, plus some data from the Department of Justice, and also, again, the data from the Department of Culture, Arts, Heritage, and Gaeltacht. In Iceland, we worked with the Ministry of Foreign Affairs of Iceland, who had quite a lot of data, over 1 million segments. And they were also quite specific that they wanted us to develop an MT system for them using only their data and no data from other sources, which is what we did. And then we also worked with the Icelandic Met Office, a really interesting use case, where they provided 214,000 segments of their own translation memories, which we folded into the baseline system we had developed for Icelandic. And then we worked with Standards Iceland, who provided just over 16,500 segments of their own data. In Norwegian, so we worked with Bokmal. There was very, very little data available for Nynorsk, and so that's not included in this presentation, though I'm happy to talk a little bit more about what we've done very recently with Nynorsk and give some results on that. But again, with the Ministry of Foreign Affairs in Norway, they provided over 1.7 million segments of their data, and again asked us, like with the case in Iceland, to use only their data in building an MT system for them and no other data. And then we worked with Standards Norway, who provided 132,000 segments, which we folded in on top of the baseline system we had developed for Norwegian Bokmal. So I won't have time to go through evaluations that we did for all of those engines and for all of those early adopters, but I've chosen 3 samples that I can talk through in terms of what we've done for evaluation of the engines. So in all cases, each of the early adopters was asked to develop a test set, which was to be used by DCU. As I said, DCU was the project coordinator, but also was responsible for leading the evaluation effort. And so for each of the early adopter engines, they evaluated them using both automatic and manual means. So the early adopters provided test sets that included segments that had not been provided within the training data, that were representative of the texts to be translated, that were created using wholly professional translation approach and no MT, and that did not contain any confidential material. And then in terms of human evaluation protocols, each early adopter was offered the choice from a menu that included comparative ranking, adequacy and fluency evaluation, direct assessment, comprehension, and post-editing or MT error analysis. So if we look first at the Ministry of Foreign Affairs from Norway, as you'll recall, we built an engine from for them using only their data. The first sanity check is to compare the principal engine against publicly available engines on the MFA test set, which you see here. And then from the menu of manual evaluation options, the MFA Norway selected to do a blind evaluation of two engines, the principal engine compared to the best publicly available engine. And as you'll see, there were 3 different evaluators, 2 of which did the full 500 segment test set, and the third evaluator judged half of the segments. And essentially, in 70% of the cases in the segments, Iconic's the principal engine was considered to be at least equal or better than the comparator online system. That 70% is broken down as 46% of the time the principal engine being considered best, and 23% of the time the principal engine and the online engine being considered equally good. In the case of Forest Nagelga, there was an issue with 4 of the test set segments that were provided. So we ended up with 496 segments in their test set. Again, as a first step, DCU conducted an automatic evaluation using Blue scores for the principal engine compared to some online options. And then Forest Nagelga undertook an adequacy and fluency evaluation of the principal engine using their 496 test set segments. There were 2 translators who were tasked with doing the adequacy and fluency evaluation. The questions being, for adequacy, how much of the information and meaning expressed in the source is conveyed accurately in the translation, and then for fluency, obviously, how fluent is the translation. So you'll see that the 2 translators on average rated adequacy at 3.57 with a mode of 4, and fluency at 3.36 with a mode of 4. DCU also conducted an inter-translator agreement test using Cohen's kappa, and in general sort of observed a low agreement between the translators, which upon further analysis they traced to the fact that translator 2 tended to stick to the choices of only score 2 and 3 rather than using 1 and 4, versus translator 1 who used the full scoring range in assessing. And then finally, if we look at the Met Office Iceland, which has got really interesting content, challenging content, because it's quite technical in terms of tidal forecasts, shipping forecasts, meteorological forecasts, with a lot of abbreviations. And so what DCU found in sort of their automated metric test with the online engines is that the online engines just didn't perform well with this content, whereas the principal engine, which was trained with the content, performed well on the test set. The Met Office undertook a post-editing exercise. Now, I will say, unfortunately, while they did the post-editing exercise, they didn't undertake a reference task, for example, translating from scratch. So while we can see that the 2 translators who participated in the evaluation reached an average translation speed of 5.7 seconds per sentence and 4.7 seconds per sentence, we don't have the comparator reference point to what that would have been if they were translating from scratch. And again, DCU dug a little deeper to see the results of TER scores comparing the post-edit result to the original, and the MT to the original reference translation, and also looked at H-TER measures on the final post-edited result compared to the MT output. They also noted from that translator 2 in general performed fewer post-edits, which probably informs why they were faster on the task than translator 1. So overall, all of the engines, the MT engines that were developed in principle were, as I said, deployed and given access to the early adopters. Most of them work on the same use case, which is MT in a translation workflow with professional translators. So in terms of deployment, most of them are working with the MT engine through the Trados CAT tool. And it's great to see that over the course of the project, we've seen almost 1 million words being processed through principal MT engines by the early adopters. And also in general, very good feedback from the translators across the board in terms of the quality of the machine translation output that they're working with and the productivity that they're achieving in working with MT post-editing. So at that point, I'd like to thank you for your participation, and I'm happy to take questions in the Q&A session, or I can also talk a little bit about what we've been doing very recently with NINORS.
Thank you, Paul Rick, for pulling the ready baked dish out of the oven, as you said. Questions are beginning to come in for Dr. Sheridan. We'll post them directly to him, and then at the top of the hour, we'll entertain questions, the ones you've already entered, or additional questions for all of our presenters during this very good hour. Arl Lamel asks makes an interesting comment, Paul Rick, the challenges of inter-annotator agreement. Not surprising, a very tough problem with no solution. I take it you would agree.
I do agree with that. Yeah, I saw that comment, and I mean, in this case, in the principal project, we were in a situation where we had a lot of partners and collaboration where we were trying to do a little bit of evaluation, also constrained by their resources, because they were essentially funding the evaluation with their own resources. So in many of the cases, we saw that there were maximum 2 translators getting involved, versus in other cases where we might want to do a deeper evaluation, we would typically look for more resources to get involved in the evaluation. But in this project, we sort of worked with what we had access to.
Thank you. And before we leave that question, we should thank Arl for his very good and very visionary keynote earlier in the week. Thank you. Thank you, Arl.
Yes.
Laura has asked, are annotators trained in advance to try and mitigate some of these issues, such as those that Arl's recommended?
Yeah, and I think, again, that would be one of the mitigating factors, is to do as much training as possible with the people undertaking the evaluation. And again, I think we were perhaps a little hamstrung in this project because there was a chain between DCU as the evaluation coordinator, the local partner in each of the countries, and then the early adopter, and then their translators. And DCU did go through training in each case, but we, again, I'll refer back to, we had quite a menu of different evaluations because we wanted to give the early adopters the choice to see what evaluation was going to suit them best and suit their resources best. So we found different countries, different early adopters undertaking different kinds of evaluation. But yet, to come back to it, we did as much training as we could within the constraints of the project to try to mitigate that issue.
And an additional question, were all the use cases are related to the public sector?
So in terms of use cases, yes, it was interesting. We found some similarity across the board. We didn't start out with a particular use case in mind, but the kinds of early adopters that came on board. So for example, we found that the ministries of foreign affairs for Croatia, Iceland, and Norway all became early adopters. So they have the same use case in that they need to provide local translations of centralized European legislation and European court decisions. And they have a workflow set up to do that. And so it was another commonality that it goes back to an earlier question that Alan had asked around, publishing raw versus post-editing. In all of the early adopter use cases with this project, translators were in the loop. It was always going to be post-edited as part of the workflow before any content would reach its final destination. And that speaks to the kind of early adopters who came on board and the kind of content that they were translating. Meteorological office or standards would never be published raw MT. They were always going to be reviewed, post-edited, and quality assured before publication.
Elena Margola asks, after the early adopters, do you plan on commercializing the engines for the public? And in fact, that's related to another question from Konstantin Dranj. What's the long-term life for this solution, and who's footing the maintenance bill?
Yes, so the project is set up so that the early adopters have free access to the engines during the course of the project, which ultimately comes to the end of this month. And under what's called the exploitation plan that all of these projects have, it had always been our intention that the early adopters who wanted to continue using these engines or other language weaver engines, as the case may be, could enter into a commercial agreement with Language Weaver, our normal sort of agreements with customers to continue access to these engines past the end of the project.
Thank you all. Thank you, Paul Rick in particular. We are at the top of the hour. So in fact, I'm going to, along with Laura, ask all of our presenters to turn their cameras on and we will pose questions. We have about 19 minutes for questions that have already been answered, and all of our presenters are here and asking and answering your questions. I know several of them have been answered in chat, but I hope you won't mind, even if you've answered them in chat, if I ask them again so that the entire group can hear some of your responses. Mercedes, one question that came in for you from Silvio Piccini: have you considered using other MT metrics such as Comet?
Yes, I replied on the chat, and well, we have used other metrics like BLE, DER, F measure, but we could use also this one, but we didn't. Yeah.
And
the test will be available and anyone can also evaluate it. Yeah.
Yes, so perfectly. That was the next question. You are planning to share the test set. I saw that you had responded, which is wonderful news. Please do also continue to put your questions into the chat. We would love that you continue interacting with our guests.
There was a question for Dr. Johnson and Ms. Jaikat about if they create a tailored model for every client, and what's the minimum amount of data that one needs to create the robust models.
Well, not all clients need or request to have a tailored model. It depends on the domain and the clients themselves. For the amount of data, as we explained, not only the quantity of data that is important, but the quality plays a major role as well. So we had a use case where the client provided around 200K segments, which got reduced by 80% after running through our picky data pipeline. So the model still performed better than the generic model, but not as much as the other tailored models. So.
Thank you. I also have been informed, I've been remiss, we do want to mention our sponsors once more in our new segment. Please allow me to break in and thank Vistatech, Yandex Cloud, Intento, and Microsoft in particular for their support of this particular track today. Paul Rick, a question for you. I saw the linguistics in your background, so I hope you won't mind me asking a linguistics question. Did any of the languages you worked on have particular linguistic challenges, morphological complexity or others that you might point out in particular?
Well, I happen to know that in the case of Irish, yes, that is the case. But having said that, there wasn't anything particular that we did in preparing the MT systems that was specifically addressed towards the linguistic issues of any of the languages. It was sort of a data-driven exercise. And then what it wasn't presented here, but what we did over the course of the project is that as we deployed the engines for the early adopters and they put them into their daily use, we did do several iterations of feedback from the translators for common issues that they were finding, sort of interrupting their work, and did a couple of iterations of either updating the training of the engines, or in some cases pre-processing or post-processing, or forcing terminological issues to terminology choices so that it would improve the experience of the translators using the engines.
Thank you very much.
I was also curious about the Irish, Dr. Reardon. I think I noticed that there were fewer segments that you had for training for Irish, and did you see kind of diminished results as well compared to the other languages?
Yes, and it is true in general for all of these languages. If I looked at across the early adopters across all of the languages, there's obviously a correlation between the amount of data that we've gotten from the early adopter and how well the engine performs on their content. It comes back to this topic of engines performing better when trained, particularly, in the case of, I use the example of the Met Office, where you've got very specialized content and very specialized terminology. You're always going to do better with more training data from that use case and from that content type. And that was the case in Irish. There was another experiment we did. It's not included in the presentation with NUI Galway, who had very, very little data. And we ended up with them, instead of working with the engine we had trained with just their data, going back to bring more data into the pool in order to improve the quality of the engine that they were using.
And pardon the layperson question, but for Irish, I think of it as a quote weird language. So does the engine, and I love it being from an Irish company, does the engine respond, you know, are the results funny because of that, or am I mistaken?
No, it's a beautiful language for sure. I'll say that. And yes, the MT engines actually work well. So they've been in, and we had previously done work with the Department of Arts, Heritage and Gaeltacht, where they had an engine in use every day for their work on translating ministerial speeches and different things like that. And so we've got some good experience in using MT for Irish successfully.
Thank you. Interesting. I see a question, Pete.
Actually, I was going to ask an old one, and I know it's for Dr. Garcia. I know you answered Elaine O'Curran's question already in chat, but could you talk about your test set? Because the answer is quite interesting. Mercedes, it's very much based in whole documents, correct?
Yes, we wanted to do it like a real scenario with a whole document, so it's not random sentences. So, and this test is separated from training, and is about, well, it's 2,000 sentences for the automatic metrics, and for the evaluators it was 500. And it's common for all the 24 languages. It's the DGT domain. I think I didn't forget anything.
No, that's important. Thank you. But I wanted to note the very unique features of that approach. There's also another question for you, Dr. Garcia. Regarding the evaluation tool that's to be launched at the end of the month, what programming language is it written in?
Sorry, it was right in here.
The very last question. The very last question.
Okay. What programming language is it? I don't know. It's an interface, web interface.
Okay.
I think it's React. Yeah. It's web interface is quite simple, and it will be available open source. Yes.
Very nice. Thank you.
Okay.
Please do other questions or that we might add to the group for their wonderful presentations.
There was one from Judith.
Ah, yes. Can you go ahead and read that, Laura?
Sure. Okay, so this one is for Dr. Johnson and Ms. Jaicot. Thank you for your interesting and clear presentation. How long did it take to create the final system, and what was the most difficult part?
Thank you. So when we had the process in place, so now when we create a tailored model, it depends a little bit on the data set, I would say, how long it takes, but more or less 3 weeks it takes if we have people focus. I think our biggest problem now is that we are a small team, and it's an AI team. We don't only do machine translation, we do also other things. So if we have people available, then in 3 weeks, we can have a model ready for our clients. And what was the most difficult part? Well, when it comes to, for this specific model on the e-commerce data, what's very tricky there is all these named entities and product names, to make sure that they are translated when they should be translated, and transliterated when they should be transliterated, and just say in English, right? That's the trickiest part for the translators, and that was also the trickiest part for the model.
Mm-hmm. There was another one for you, and that was about the quality of the client data. How does the quality of the client data impact the performance of the resulting models?
Do you want to take that, Ruba, or should I?
Yeah, okay.
Yeah.
So it does affect a lot. Let's say, as I mentioned, we had this client which provided 200K segments, which got reduced by 80%. So it does quite affect the model. It's still performing better than the generic model. However, we need to find similar data, like the same domain, same translation guidelines and style, so that we can like cover a little bit on the same domain of the client. So I hope I answered the question.
Oh, thank you. Perfect. I was going to ask Mercedes the same question I asked Parik. Did you face any particular linguistic challenges? I noticed you had very solid results, for example, in Hungarian and Finnish, two very morphologically complex languages. Were there any other languages that linguistically were very interesting? You also mentioned Maltese as well, correct?
Well, as we did it in domain, the surprising, well, we didn't do a further linguistic analysis, but if we compare it to Google, and it was much better than Google in those languages that are more difficult, because we did it without pivoting and in domain. So the quality sometimes in BLE was lower than other more common languages, but it's also harder to do it. So,
Perfect. Thank you. And another question just came in for you, Mercedes, as well. What resources from the EU did you use to build the engines? Did you use only official documents or other sources as well?
we used the DGT dataset. Yes. Other open source documents, and it will be available. We filter this data and we did back translation and make more data available.
Perfect. Thank you. Other questions for our presenters?
I don't mind asking another layperson question.
Perfect.
If you forgive me. And can you tell me how to say your name again? Is it, how do I say Parik?
Parik.
Parik, sorry.
Yes.
Parik. So going back to the Irish, and forgive me again for the layperson question. So is the Irish, the languages that are going to indicate kind of a poor performance can be those complex kind of grammatically and syntax wise. So can you describe what Irish is like?
So yeah, it's interesting because back in the day when we started at Iconic, we were still using statistical machine translation, and then we would have a list of languages that we thought were going to do well with MT and languages we knew were really not going to do well with MT. And since we've all moved to the neural paradigm and are building neural MT engines, it's no longer the case really that a specific language is going to be on a blacklist where we say, oh, we're going to avoid that language. It's just not going to do well. And so it's going to come down much more to the data and the data training fit to the customer's use case and what kind of content is actually going to be translated. So I think we've moved away from this situation where certain languages, inherently are going to be problematic for MT, and it's going to be a case of looking at the use case and looking at what set of training data or and what domain it's involved in, what you're using to build the engine, and then what the engine is being used for.
Oh, that makes sense. Yeah, that makes sense and jives with our findings. And if I'm thinking about the projects that I've been a part of in my limited.
Sure.
Thank you.
And Parik, can you talk a little bit about your domains as well? I noticed in many ways they were similar, for example, to the work Mercedes described, but I saw that e-health and procurement were also specifically called out. So there
Yeah.
seemed to be something of a breadth there. Am I correct?
Yeah, so what you'll find is that the Mercedes presentation on her project and the presentation I gave on the principal project, there's a lot of similarities because they're funded under the same vehicle by the European Commission, under the Connecting Europe facility. And so they're both contributing towards the European Commission's stated aim of building machine translation across all of the languages. And I referred to what they call the digital services infrastructure. There's 5 pillars of digital services in the European program, one of which is machine translation, but others relate to electronic procurement, standardized procurement across Europe, e-health, e-justice, online dispute resolution. And so you'll find common themes in the projects that are working towards MT under the CEF program, that they tend to focus on these pillars of justice, health, procurement, and so on.
Very nice. Thank you. Laura, I see there's one more question for Rebecca and Ruba.
Yes, I see. So for the e-commerce MT system, did you use only customer data from the translation memory, we suppose, or did you also gather generic data?
Okay, so first of all, in this case, it wasn't from the translation memory. We don't know. So the client sent over this data from us. How they had translated it, we don't really know. If they were using some other TMS system, but it wasn't done in our TMS system. So we got the data from them. And regarding gathering generic data, so we were using our Tarjama data from different domains to train the model. We wanted to see if we could use other e-commerce data from other, but that didn't really benefit the model. We have tried to try our e-commerce model bit here on other e-commerce data, but it's not really showing any beneficial effect from. They are very different, the different e-commerce clients we have actually. So, but yes, we are always using more data from other places, both external data and then Tarjama data, but very picky with the data we choose.
That makes sense. Yes, I'm imagining garbage in, garbage out. You must use good data.
Yeah.
Very good. And then Pete, I saw a question that was coming again back to Park about if there was going to be access for Irish made free for MT or corpus for MT.
Yeah, I was just replying there in chat that the ELRC share is a good place to check for resources for European languages, because all of these projects being funded by the European Commission are generally uploading the resources into ELRC share. I know that I think most of the data that's there is publicly available. Some of it comes with licensing restrictions, but that's back to the original data owners. But certainly there's a drive that all of this data being collected from the public sector in Europe should be publicly shared for use in AI tools.
What a wonderful.
Thanks, Tariq. Hi, sorry, can I follow up? Sorry, I joined this present later, but I have some, in case other people ask, I apologize. So when you do machine translation on Irish to other language, is there specific challenges that Irish language have that compared to other language to the MT researcher need to address? Like for example, terminologies or some idiomatic things from Irish that like that?
Yeah, so that's a good question, and it sort of echoes what Pete was asking earlier about Irish. And I think you'll find that yes, it's a very idiomatic language in general, but I guess it's down to the use case that we were focused on, because we're translating legal text for the Oireachtas Astrakhan. So there's not a lot of idiomatic use within that particular domain. And a lot of the domain-specific terminology that the translators cared a lot about, in general, was being captured through the training process on the training data, which they had provided. And then once the engines went into use, terminology that wasn't being captured or wasn't being captured correctly, we did have the opportunity to work on several iterations of feedback from the translators to build that terminology into the engine specifically.
And on that note, we are going to have to say goodbye and move over to the General Assembly, but please join me in chat in thanking our wonderful set of presenters and presentations, very enriching this morning. Thank you all for your work, and we look forward to seeing everybody in the General Assembly in just a few moments. Thank you again. presenters and all for joining and for very good question and answer and discussion afterward. We appreciate everybody's presentation. Thank you all.
Thanks. Bye-bye.
Bye-bye.